Okay, so this section will be actually section 2.4 A will be about solving quadratic equations. Solving quadratic equations. So we will find multiple methods as we solve quadratic equations. And the first one will be solving by factoring. Obviously, from MAT 1033, we've gone through different methods. Well, you can find me using some of the methods in different problems. In this one, we will be using factorization. So one thing that you need to keep in mind is when you're solving quadratic equations, you must keep the equation, start the process by putting your equations in standard form. So standard form will be a x squared plus bx plus c equals 0, where a, b, c are real numbers. A, b, c, well, let's say a is not 0, because if a is 0, then you will end up having a linear equation with the highest exponent being 1, the coefficient, the term in b. The term in b exponent is 1 if you don't have this term. So you want to keep the a not equal 0 so that your equation remains a quadratic equation, meaning that the highest exponent being 2. And then you can have b and c, they can be any real numbers. They can be any real numbers. If they're 0, then we will make some consideration. For example, if b is 0, then you're going to have two terms in x, 1x squared, 1x, that you can factor x out to solve. You solve by factoring. And if b is 0, that's what you do, you factor. So say, for example, you have b 0, then you're going to have an expression like this, ax squared plus c. Then you're going to solve using square root property. And then if c is 0, then you're going to have ax squared plus bx equals 0. You're going to solve by factoring the GCF here. The GCF will be x. And we're going to solve one of each example here. Let's start with this example here. We're going to solve a problem similar to each of these two examples. But the first one is when a not 0. When a not 0, that's one of the situations, or everything is non-zero. A, B, C are non-zero, then you're going to have to solve it by factoring. So here, let's write down the equation. 2z squared plus 11z equals negative 15. We're going to start putting this in standard form. So we're going to add 15 on both sides. So that is 2z squared plus 11z plus 15 equals 0. Now, if you remember, when you factor a trinomial of second degree, and the coefficient of the squared term is not 1, you may want to multiply A and C. So let me call A here equals 2, B equals 11, and C equals 15. Now, A times C equals 2 times 15 equals 30. Now, we need two factors of 30 that the sum is 11. So you multiply A times A and C, and you need two factors of A times C that the sum is B. So you want A times C equals something, and then A plus C equals B. Two factors of A times C that the sum is B. Let's say that this way instead. So what are two factors of 30 that the sum is 11? Some of you may start to think and found that it's 5 and 6, or 6, 5. So if we write the 11z as 6z plus 5z, which doesn't change the actual 11z, but whenever I'm doing this by grouping, by the way, I'm factoring this trinomial by grouping. Factor by grouping. So, you know, when you factor by grouping, you need 4 terms, and this one is 3. That's why I managed to find 2 terms from the 11z, in this case, 6z plus 5z, and there's a exact specific way of doing it, and that's exactly what I did. First, you multiply A and C, coefficient of the z squared, and the constant, you multiply them together to get a number, and that number, you will be able to factor by grouping only if you can factor it out into 2 numbers that when you add them, the result is the coefficient of z or x, or the linear term. In this case, the b coefficient of the linear term is 11, a is 2, and b is 15. When multiplying the 2, we get 30. Now, the 30 that we got, we're going to factor it out into 2 numbers that the sum is 11. B. If we can't do that, then you cannot factor those numbers by this trinomial by grouping. Now, because we have the 2 numbers that add up to 11, 11z will be changed into 2 terms, which will give me 4 terms for my trinomial. Then I will be able to factor by grouping, because I do need 4 terms to factor by grouping. Now those 2 terms of 11z becomes 6z plus 5z. And you can see how I cannot just decide to take 2 numbers. I cannot take 2 numbers like 3 and 10. Will be 13. Won't work because I want 11z. So you need to make sure that the product of AC is broken into 2 factors. Sum equals the coefficient of the linear term in this equation. Clear? Now that said, we can drop down the other terms. So that's z squared, 2z squared, and then 15. So we have that. Then we can go ahead and factor by grouping. So that's one group, and then that is the second group. When we factor by grouping, you need to find the GCF of each group, factor it out, the GCF. What's the GCF of the first group? Some of you may say that's 2z. When you factor it out, you get z for the first term plus 3 for the second term. Now let's work with the second group. What's the GCF? GCF is, you may say, 5. Factor it out. It's z plus 3. That equals 0. Now we can refactor because we see that each group share the factor z plus 3. So let's factor the z plus 3 out. And then what's left for each group, first group is 2z plus 5 for the second group equals 0. And now we can use the zero product property. The zero product property says if you have a product A times B or more factors that is set to 0, then one or all of them, at least one of them is 0. So A is 0 or B is 0, or in fact, the or is inclusive, means that both of them can be 0. Now, if this is A times this is B, then we can apply the zero product property. So that is Z plus 3 equals 0, or 2Z plus 5 equals 0. Subtract 3 on both sides. Z equals -3, or subtract 5 on both sides. 2Z equals -5. Divide by 2. Z equals -5 over 2. So your solution set will be -3, comma, -5 over 2. So the Z values here, -3, -5 halves, or the solution set, -3, -5 halves. Next problem. Next problem here is another situation where we have to solve a quadratic equation. But in this case, the quadratic equation has two terms. Now, when you have two terms, it means that A or B, I mean not A, C or B, one of them is 0. In this case, the constant is not seen. That means C is 0. So C equals 0 in this case. So we got 15x squared plus 10x equals 0. That means C is 0. When C is 0, you factor the GCF. So what is the GCF of the left side? Well, I mean, obviously we need to put the equation in standard form first, and then after that you will try to factor the GCF. It's already in standard form. That's why I don't bother working on anything before factoring the GCF out. What is the GCF? I'm going to factor my negative sign out too as well, but you don't have to. If you do differently, that's also totally fine. So let me factor the GCF out, which is -5x. When I factor -5x out, what's left would be 3x minus 2, right? Equals 0. So we have two factors. If I call this one A, times, I call this one B, I can apply the zero product property negative 5x equals 0, or 3x minus 2 equals 0. So this one, to isolate x, I can just divide by negative 5. Then x equals 0. Or here, I can add 2 on both sides. 3x equals 2. Then divide by 3 both sides. Get x equals 2/3. The solution set here is 0, 2/3. Two solutions here, 0, 2/3. And now I can list them as 0, 2/3, or give the solution set as they ask me here, 0 and 2/3. So this is to show you how the answers are important, but the work is more valuable for me than the actual answer, the steps. You cannot get the answer with no step. So if you can do it in your head, then write the steps in your head on the paper, because work in this class is fundamental. So you need to show your work. Work is fundamental. Next problem. The next problem, as you can see, includes fractions, but it's not quite a quadratic equation. Why? Because the highest degree of the variable is not 2. So that's the only reason that explains why it's not quadratic. But it's important for me to solve those type of equations, because sometimes you can have a quadratic equation with fractions, and now the purpose is to show you how to manage with fractions. So fractions here, you need to find the least common denominator. So let me write the problem down. 1/7, 1/7 equals z plus 2/18 and minus z plus 3 over 6. Now I'm going to find the least common denominator for 7, 18, and 6. Well, because 6 is a factor of 18, now I'm not gonna need to multiply. I can just use 7. LCD will be 7 times 3 times 6. Well, 3 times 6 is 18, but I broke it down for you to see that 6 is also represented in my GCF, but I don't need 6 twice since I'm looking for the least common denominator. So then that's going to be 126. 126 is the least common denominator. Then what do you do with the least common denominator? Obviously, we're going to multiply each fraction by this LCD. So I multiply by 126 here, multiply by 126 here, and multiply by 126 over here as well. So that will allow me to clear the fractions and move on with a most simpler equations. Most simplified equation. So when you divide 126 by 7, that's going to be 18 equals, when you divide 126 by 18, that is 7. So that means you cancel 18 times z plus 2. And then when you divide 126 by 6, then you got 21 minus 21 z plus 3. Then now you can distribute and then isolate the z. 18 equals 7z plus 14 minus 21z minus 63. Combine like terms, this side is just 18. That's negative 14z. We combine 7z and negative 21z. And then 14 minus 60, 14 minus 63 will be negative 49. And now we can add 49 on both sides. Then you get 67 equals negative 14z. Divide by negative 14. Z will be that fraction negative 67 over 14. It's the reduced fraction. So your solution will be the single element negative 67 over 14. So Z is negative 67 over 14, or the solution set is negative 67 in braces over 14. Our next example here will be about using the square root property. But before we do example 4, I'm gonna want to do example 5 with you because it's more simple than the other one. If you can do this one, then and you will be able to do the next one. Now, one thing that I want to point out for this example is that you're gonna check whether you have variables in each term of your equation. Now, one reason why you want to check this is because you want to make sure whether you're going to want to move all the terms in one side. That's when you have mixed exponent in your variable, like you have b squared, b to the third. Whenever you have different exponent for the same variable in your equation, then you want to zero this equation out, meaning you want to put it in standard form. And if you have only one term that has variable, all the terms are constant, then you want to isolate that one term and solve for the variable no matter what the exponent is. So in this case, what do you see? For this term, I see b, but no other term has a variable. So I'm gonna want to isolate that term with the variable here and solve, or isolate that one term, then solve for the variable. So to isolate, then you're gonna want to add 8 on both sides in this case. So when you add 8 on both sides, you're gonna have negative 4b squared equals 196, right? Then you divide by negative 4, and then b squared equals negative 49. So that's b squared, but we're solving for b. Now, knowing that you can take the square root of both sides to isolate the b, so I take square root of b squared, that equals to, always remember, when you take the square root of a squared equals b, well, let's say a squared equals b. If a squared equals b, then a equals 2 values plus or minus the square root of b. 2 values, 2 possible solutions. So square root of negative 49. Now, another thing that you need to remember from that is if you have a square root of negative 1, that equals I, because I squared is negative 1. In this case, you can separate this solution as plus or minus square root of -1 times square root of 49. The 49, square root of 49 is the regular radical of 49, which is 7. And then, so that's plus or minus 7. That is 7i. So we have two solutions, complex, obviously, because you have the I, but still the solutions exist because they are complex numbers. They are numbers. They're not real numbers, but they are complex numbers, which are also numbers. So the solution set is 7i and -7i. So B is plus or minus 7i, and the solution set, say, or your solution set is 7i or -7i. Or you can just set your solution set is plus or minus 7i, which is also perfectly fine. Now, solving this, we can apply the same techniques to solve the problem, example number 4. The example number 4 is more complicated because the square part, the expression squared, is a multiple term expression, but it's the same thing. You should remember that if I have a squared equals b, then a equals plus minus the square root of b. Now, in this case, the a is x minus 6. That was squared. So let me write it down. X minus 6 squared equals 5. Then you can have the square root of both sides. X minus 6 squared equals plus minus the square root of 5. Yes? And then that takes me to this equation. X minus 6 equals plus minus square root of 5, because square root of, just like you had here, remember that, right? So then you have this result. And then now we're solving for x. I can just add 6 on both sides, and then x is 6 plus minus the square root of 5. That is the value of x. Or your solution set can be 6 plus minus square root of 5. Or if you want to separate the solutions, you can write it as 6 plus square root of 5, comma, 6 minus square root of 5, which you don't have to. Okay? So that's x equals 6 plus minus square root of 5, or I'm going to separate it. But like I said, you can keep it condensed. It's not a problem. So 6 plus square root of 5, comma, 6 minus square root of 5. Okay. So that was, if you want to solve by using the square root property. The next few examples, though, will be about solving using the quadratic formula. Now, talking about the quadratic formula, we first need to write the equation in standard form. So this equation in standard form would require me to move the terms. I always like to move the non-square terms. So that's why even if I have more terms on the right than on the left, I want my terms that are now not squared to be moved so I can keep my square term with the positive sign. If it was negative, then I would prefer moving it, but I would always write my expression on the left and then equals 0. So I add 53 on both sides, minus 6x. And then on the other side, I do the same thing, plus 53 minus 6x. This will take me to the standard form of my equation, which is x squared minus 6x plus 53 plus 53 equals 0. Equation in standard form, so I have A equals 1, B equals -6, and C equals 53. The quadratic equation, the quadratic formula will be x. In this case, the x solution will be found using the parameters a, b, c. So a equals, let me put the formula, that's negative b plus or minus the square root of b squared minus negative b squared minus 4ac over 2 times a. Now we have the formula. Let's plug in. So x equals, b is -6, negative b will be +6. You switch the signs. So 6 plus minus the square root of -6 squared, b squared, -6 squared, minus 4. A is 1, C is 53. Now we're going to perform this operation inside of the radical so we can simplify. So x equals 6 plus minus square root of, that's 36. See, 36, -6 squared is not -36 actually. It's 36 because it's -6 times -6. Negative times negative is positive, and then 6 times 6, 36. Always remember that. And then 4 times, it's a minus 4 times 53. That is 212 over 2. Now we still need to simplify this. This equals 6 plus minus square root of, so that's 212 minus negative 212 plus 36. That's -1. That's -1 60 176. So that's -176. And please do not forget that you can solve the square root of a negative number as long as you remember that square root of -1 equals I. So this will be a complex, two complex solutions where you have x equals 6 plus or minus I square root of, because this is square root of -1 times square root of 176. This is I. This one, you're gonna wanna break it down to make sure you find the mixed radical form of it by simplifying, by dividing 176, find the largest perfect square that is a factor of 176. I'll show you how to break it down. But by the way, here, that's going to be I plus or minus I square root of 176 over 2. Now let's work with 176 to see what is the largest perfect square that goes into 176. Start with 2 because it's an even number. So divide 176 by 2. That gives me -8. That give me 88 because I don't have to work with the negative because I consider square root of -1 equals I. So that's 88. Now work again. 2. I just want to go by 2 until I can't anymore. So 44, 2, 22, 2 again, 11. So 11 will be by itself inside of the radical because I see that I won't be able to group it. But since I'm solving a square root, I group the common factors by 2. And each group of 2 will be will send a factor on the outside of the radical. So another factor 2 that will go outside, and the outside factors multiply, then that's a 4 on the outside of the radical. I have a 4 outside. And then 11, I couldn't group it by 2. There wasn't any other factor 11 that goes into 176. That means the radical, we're going to have a mixed radical with the 4 on the outside of the radical. And then the 11 will be inside of the radical. So this expression will be simplified as 6 plus or minus 4i, the 4 outside 4, square root of 11 that we kept inside because it did not have a pair of factor. And then we have a 2 on the outside. Now we can simplify by 2 because all the terms are multiples of 2. Then that is x equals 3 plus or minus 2i square root of 11. In your solution set, this one, I'm going to write it as one condensed solution with the plus or minus 3 plus or minus 2i square root of 11. So we have the solutions for x in the solution set of the equation. Solution set is with the braces, and then x equals 3 plus or minus 2i square root of 11. So that's how you use the quadratic formula. The next problem will be also about the quadratic formula. I'm going to bring my quadratic formula down here for the next example, 7. But the variable is p, so that's not going to be x. We're going to have p equals that. So obviously in this, we already have the standard form. A equals 25. 25. B equals negative 20. And C equals negative 59. Now we can just substitute the A, B, C values. So P equals B is negative 20, so negative B will be just 20, plus minus the square root of B squared, negative 20 squared, plus, actually minus 4. A is 25, C is negative 59, over 2 times A, 25. So the value of P will be 20 plus or minus the square root of, actually smaller square root here, 20, negative 20 square is positive 400. So that's gonna be plus because I have a minus sign for the negative 4 and also a minus sign with that. That means I'm going to end up with a positive sign, right? So that's 4 times 25 and times 59. Times 59. 4 times 25 times 59. Okay. And then so that is 5,900. And then over 50. We continue with the simplification. 20 plus or minus the square root of 400 plus 5,900 will be 6,300, right? Over over 50. Well, this, we can break it down. I mean, there are multiple ways of solving this, but since I've already seen most of the factors of 66,300, I can start breaking it down. So that's going to be 20. Again, this is not the only way of doing it. You can take the 6,300 and break it down, see all the factors, but you can factor it out in two factors, perfect square factors, and see what it comes down to. But I see that that's going to be square root of 100 times square root of 9 times square root of 7, which makes it easy for me to simplify this, right? If you can factor it into perfect squares only, and then the only one that's going to be not a perfect square is square root of 7, and 7 being a prime number. So that's going to be perfect for me. And this one will be 3, and this one is 10, and multiply them together, that's 30. So life is easy to find P equals 20 plus or minus 30 square root of 7 over 50. Then easily now I can think about factoring, well, simplifying by 10, because all the numbers in denominator and numerator, they are multiples of 10, and 10 is the largest factor that the top numbers and the bottom numbers share. I can simplify by 10. So my solution is 2 plus minus 3 square root of 7 over 5. And you can keep it as a condensed form. So that's 2 plus minus 3 square root of 7 over 5. Keep it in condensed form, or separate the plus and the minus, it doesn't matter. So your solutions are 2 plus 3 square root of 7 over 5, or you can write it in solution set. That is, since you were solving an equation, you present your solution as 2 plus or minus 3 square root of 7 over 5. So that's it for topic 2.5, 2.4a.